So this was the example we had seen, and of course, I kept coming up with a solution which looked really odd. And I know I had talked about how that solution did not look right. So what happened was when we started solving this and we did that first part where we took equations 2 and 3 and tried to reduce it down to two variables, two equations, and we had gotten a false statement. I actually needed to stop right there because if the two equations did not work out, which is telling us that there's something going on between 2 and 3 because there was no contact between the two, right? If we got a false statement, then that's actually telling us there is no solution between those two equations. And since we're trying to find the solution of the entire system, if two of the equations doesn't work, it doesn't matter if the remaining two equations combine with each other somehow or not, because that was the key. And then, of course, I kept going, hoping that we would come up with something, but I actually did not need to keep going. So that was our key, that this is where we needed to stop. So what I did afterwards, once I realized the error I was making, and I have posted these notes under your spring 2024 review section, so you can find the notes where they are. But I went to Desmos and I graphed this to see what was going on. And I don't know if you guys had a chance to look at the email I had sent out, but you will see those equations 1 and 2 over here. And those are these two equations right here. They're actually parallel to each other. So that's why those two equations did not work out like we wanted to, because like I said, if you got a false statement, that kind of tells you something was not touching, or, there was no connection between the two. So it doesn't matter. And you will see that third plane does intersect both of them, right? But because the first two planes have nothing in common, the whole system is not going to have a solution. So this was actually a no solution system. And you can see that when we try to put the solution in, it may actually be in here. The correct answer was the solution set is an empty set, and that's why it's coming up, because we had no solution to this. So be mindful of that. That's something I wanted to point out, since that was something I did not pay attention to, is if you do end up getting a false statement, maybe go and do a 3D graph of that to see, are those two planes parallel? Because then yeah, you're not gonna have a solution. So that's what I wanted to point out to you guys, and you will see I went ahead and canceled out all that repetition I kept doing, because I should have made notice that, hey, those two equations are not working. Sorry, those were equations 1 and 2 were not working. Our system is not going to have a solution. So again, this is available to you in B2L under your chapter 5 spring 2024 viewing section. Okay? Alrighty, guys. So today we are working on bring this up. This. This one will take a little space to work through all 3 of those. Let's copy over our points here. So remember, our ultimate goal is to come up with the equation of the parabola. It's plus b plus c. And our 3 points that are given to us are 2 and -2. Let's see, -2, -10. 4 and negative coming together. So the first thing we actually have to do is, because you can see these guys are ordered pairs, right? Which means each of the pairs is giving you an X and Y coordinate. So we are actually going to take those X and Y values into that format of the equation for a parabola and come up with the three equations for our system. So we need to first come up with the equations before we can solve them. So you can think of these guys as coming for equation 1. This would be for equation 2. This would be for equation 3. So for equation 1, your Y value is -2, right? Because that's what's given to us in the ordered pair. We have A, which we don't know at this point, and X is +2, so that would become 2 squared, plus we don't know the B value, but again, X is +2, and we don't know the C value, right? So cleaning this up, we have -2 on the left-hand side. 2 squared will become 4, so that becomes 4A. Plus 2 times B will be 2B. And then of course, C will stay as it is. So that's our equation 1. We'll do equation 2 next. So this time your Y2 value that I've assigned is -10. Again, A stays as it is. Your X is -2, so that becomes -2 squared plus B times -2 plus C. So clean that up. We'll have -10 on the left-hand side. And again, guys, if I go too fast or you have a question, just stop me and ask me. Don't hesitate. All right, so cleaning that guy up, we have -10 on the left. Now you have -2, the whole thing squared, right? So negative and negative will become positive. So that will also end up giving us 4A. But in the middle term, we are multiplying positive B with -2. So this will actually end up becoming -2B. And then of course, the plus C will stay as is. The last one, equation 3. So again, for equation 3, our Y value is -22. X is 4, so that will become 4 squared. Plus B times 4 plus C, which will of course clean up into, let's see, -22 on the left. 4 squared would be 4 times 4, which is 16A, plus 4B, plus C. Everybody with me on how we came up with the 3 equations? Using those 3 ordered pairs? Yeah.
On the second equation, is the exponent 2 supposed to be?
Are you talking about that exponent?
Yes.
No, because remember that's coming from this equation and it will stay as positive, exponent. Yeah, very good. Any other questions, Papa? Anybody on Zoom, Daniela, Danny? Yeah.
I thought -2 to the power 2 is -4.
No, because you are doing the square on the X and your X happens to be -2. So it's actually -2 and then the square on the outside. So you do end up doing negative times negative. And I'm glad you asked that. Because remember how I was telling you everything kind of follows each other. So if we do make that error of keeping the negative here, that will follow us all the way to the end, right? Which means we'll actually end up with the incorrect answer. So be very careful since the X value is -2 itself and you're squaring the X, the negative does get squared. Yeah? Okay, good. Okay, so let's put the 3 equations together so we can start solving them. And again, my brain works better if I have my variables on the left and my equations on the right, guys. So I am actually going to move those Y values to the right-hand side. So like your first equation is going to be 4A plus 2B plus C. And we had -2, so that's equation 1. Then we had 4A minus 2B plus C equals -10. That was our equation 2. And the last one was 16A plus 4B plus C equals negative 22, and that one was equation 3. So this is where we now have to choose, do I want to eliminate variable A, B, or C? And again, remember, you want to go for whichever one you think might be the easier one. So which one do you think might be easy to eliminate, A, B, or C? B, because you kind of have the built-in negative sign in there, right? You've got with equation 1 and 2, positive 2B, negative 2B, which is great because we don't really even have to multiply with anything. So yeah, let's start by eliminating B. And to do this, we will basically just add equations 1 and 2. We don't have to multiply them. Adding equation, can you see that? Yeah. Adding equations 1 and 2 will be, let's see, 4A plus 2B plus C equals negative 2, and then 4A minus 2B plus C equals negative 10. We're adding the two equations together. So obviously, as you can see, 2B minus 2B positive 2B will cancel each other out. So those guys are gone, leaving us behind with, let's see, 4 plus 4 will become 8. C plus C will become 2C, and then what's that, negative 2, negative 10 will be negative 4. So let's designate him as equation 4. All right, so we did 1 and 2. Now we need to take the equation 3 with one of the others. So which one would you combine? Equation 3 and 1 or equation 3 and 2? Which one would make more sense to combine it with? Yeah, that's what I was kind of thinking. I mean, you can go with 3 and 1, but since the 2 again has the negative sign on it, it would be easier to do equations 2 and 3 combined together. So since you have 4B on equation 3, what would we need to do with equation 2? Yeah, because we need to make it into a negative 4B. So we are going to take equation 2 and multiply equation 2 by 2. And then we'll add equation 2. So let's see, we are multiplying this guy by 2, so that will end up giving us 4 times 2 is 8, so that becomes 8A, minus 2 times 2 is 4B, so minus 4B plus 2C equals what, negative 20? Bringing equation 3 down, 16A plus 4B plus C equals negative 22. And again, we are adding these equations. So negative 4B, positive 4B cancel each other out. What is that, 1624A? Plus 2 plus 1 will be 3C equals negative 42. Does that not look okay? 16. So C negative. All right, so our new system, which has been reduced down to 2 equations and 2 variables, is now 8A plus 2C equals negative 12. And then we got 24A plus 3C equals negative 42. All right, so which variable should we eliminate? A or C? A, alrighty. If you are eliminating A, you will need to multiply one or the other equation with something. So we're eliminating variable A. What are we multiplying with what? Very good. So if you're eliminating A, we need to have positive 24A and negative 24A. So yeah, multiply equation 4. And then this will add it to equation 5. Let's see, multiplying this. 3 will give us negative 24A. What is that? Negative 6B. Because negative and negative is positive, 12 times 3 is 36. Equation 5 will stay as it is, so 24A plus 3C equals negative 32. Add those two equations together. And what do we see? So A cancels out as we were hoping for, but C will stay. And you need your variable to stay, right? Because this is not gonna be one of those infinite solutions. This is the type of equation where you get one single ordered triple as your answer, because that's gonna help us find the A, B, C values, which will then lead us to the equation of the parabola. So we wanted the C to end up staying. So it looks like you have negative 6C, positive 3C, which will be what, negative 3C? And what is positive 36 minus 42? Negative 6, which is good because 3 will go into 6 evenly. And what does your C value come out to be? 2. Divide both sides by negative 3. And negatives, of course, again, cancel out. 3 goes into 6 2 times. So we have 3. So C done. Now we need to find A and B, and we'll have our 3 coefficients there. So since we did A as the previous variable that got eliminated, we need to go find A next. So you can use equation 4 or equation 5 to find A. And I think I'm going to use equation 4 just because you have a smaller number on that. So let's find A next. All right, so to find A, like I said, we're going to be using equation 4, so that was 8A plus 2C equals negative 12. And then, of course, our C value came out to be the number 2. So plug that in, and what does the A come out to be? Do we have an answer? Negative 2. Okay, let's see. So we multiply 2 times 2, which gave us 4. Move forward to the other side, becomes negative 2. Negative 4 with negative 12 is negative 16. Divide both sides by 8. And A equals negative 2. Okay, very good. So we've got A and C. So of course, the last thing to do is finding B, for which we will actually need to go back to the equation 1, 2, or 3. So last step here is finding B. Let's see what were our 3 original equations. 4A 2B plus C equals negative 2. Sure, equation 1 looks fine to me. So 4A 2. Alright, so our C was positive 2, A is negative 2. Plug those numbers in. And then what will the B value come out to be? 2, really? All A, B, and C's are coming out to be 2s. So let's see, -8 plus 2b plus 2. Combine the like terms together, so you can take these guys and add them together, which will end up giving us -6. -6 plus 2b equals -2. You are adding that 6, moving into the other side, which leaves us with 2b. 6 minus 2 is 4, and look at that, this guy does come out to be 2. Interesting. Okay, so if we put this all together. Now I'm gonna squish this in here because I don't want to do a whole new page. We're just putting our equation together. So let's see, our A value was -2. B came out to be +2. C was also +2, right? So when you put it in your parabola equation, which is y equals ax squared plus bx plus c, now what you're replacing is the a, b, and c variables, right, or the values. So this will end up becoming -2 for the a value, so -2x squared plus 2 for b, so that becomes 2x. And then c was also 2. That will be our equation for b. Questions on this? So -2, +2, +2, let's plug that in. So y equals is already given to you, so you are just plugging in the other side. So -2x squared plus 2x plus 2, let's hope we didn't make a mistake and there we. So again, as I was telling you guys last time, the process can be a little bit lengthy, but be patient. Don't try to rush through it because again, one single error at the beginning will be a cascading effect all the way till the end. So be mindful as you're going through these examples. Okay? Did anybody have any questions on this one here? Anybody on Zoom? No? Alrighty. So that was the last part we needed to talk about. Again, there's an application problem there if you guys wanted to see. This will be again under the spring 2020 lectures if you wanted to see how we did this problem here. All right, guys, so that was the last part from 5.2, sorry. The last one we need to do here is 5.3, which is where we get into nonlinear. And this is actually where a lot of the stuff we did in section 5.1 as review will show up. So like you will be able to use graphing for some of the simpler systems, to solve them and stuff like that. Okay, so a graph of nonlinear equations is not straight lines, therefore the term nonlinear. If a system has at least one nonlinear equation, it is called a nonlinear system. So not all equations have to be nonlinear, right? Even if just one of them in the system is nonlinear, the whole system becomes nonlinear. So think about parabolas, y equals 3x squared. Think about square root functions, y equals square root of x, absolute value functions, y equals absolute value of x. And then, of course, we just got done talking about exponential and logarithmic functions in chapter 4. So that's y equals 10 to the power of x or y equals log of x. Any of those would be considered as nonlinear equations. Okay, so let's take a look at an example for this guy. So they want us to solve the system algebraically. excuse me, and then we're graphing it to make sure what we solved algebraically is visible graphically also. So you will see this is a system where you have y equals x squared, which is a nonlinear equation, and then you have 7x minus y equals 10, which is actually a linear equation. So it's a combination of both linear and nonlinear. Now you can use substitution, you can use elimination to solve them algebraically. So again, you will see, guys, I've included several different types of examples on the handout for you guys to work through if you wanted to as extra practice, but let's take a look at this guy. So I say let's try substitution with this, since you do have y equals x squared on that one side. So this will be our equation. So equation 2. So we will actually go ahead and substitute equation 1 inside equation 2. So we've got 7x minus y equals 10. And since the first equation is set up as y equals something, y is where the substitution is happening. So instead of putting y in there, we're going to substitute it in equation 1, which was our x squared value. Okay. So you can see this guy ends up becoming 7x minus x squared equals 10, or if we put this in the standard format, we can take 7x, we can take x squared, move them both to the other side. So that will actually end up looking like 0 on the left-hand side. I'm moving x squared to the right, so that will become positive x squared. I'm moving 7x to the right-hand side also, so that will become negative 7x. And 10 stayed where it was, so it will stay as positive 10. So basically, we have a quadratic equation, right? X squared minus 7x plus 10 equals 0. Now, you can solve this using the techniques we had learned in chapter 2. So you can try factoring. Or what else had we done? Square root property, completing the square, quadratic formula. So any one of those which you think might be appropriate, you should be able to use here. I'm actually going to go with factoring. So two numbers that multiply to give us 10 and add up to give us negative 7. What will this guy factor into? Very good, yeah, negative 2 times negative 5 will give us positive 10, and when you add them, negative 2 plus negative 5 will add up to negative 7. So this guy will break down into x minus 5 and x minus 2 as our two factors. Set each one of those equal to 0. Yeah, Danny, very nice, negative 5, negative 2. So setting each one of these equal to 0 will give you x equals 5 or x equals 2. So once you have your x values, obviously we go back and find the y values, right? So what will each one of their corresponding y values be? And you can use equation 1 or equation 2. I think I'm just going to use equation 1. So you do x equals 5, right? Which will be 5 squared. 5 squared is 25. So your ordered pair would be x value 5, y value 25. For the other x value, x equals 2. Again, I'm just going to use the same equation. So that will become 2 squared, which is 4. So that ordered pair will be x equals 2, y equals 4. Everybody okay so far? Any questions? All right. Let's check those answers then. So solution A. And you are typing these guys in as ordered pairs. So 2, 4, comma, and then 5, 25. Okay, that is looking good. Okay, so the next part they're asking us to do is graph these two equations. So of course, y equals x squared is going to be a parabola, and you will see once I selected the parabola tool, it's telling me I need to do a 3-point quadratic tool, right? So we need to have 3 points from the graph to plot this. So your equation is y equals x squared, so you can just do a simple x and y table. -1, 0, 1, you're squaring each one of those numbers. So you can set up your table, we're doing 0, 0. You can pick larger numbers, so I'm doing 0, 0, 1, 1, and remember you can see the ordered pair in that little yellow strip above your graph, so that's how you know your mouse is on the right position. And then -1. So that will be my parabola. And then we need to do our second equation, which is a straight line, 7x minus y equals 10. So I think there should be 2 points if I remember correctly. So if you use 0 for your x value, your y comes out to be what, -10? And if I use 0 for the y, it's actually in fraction. How about we do 1 for the x value, so that would be 7, subtract that 3, -3. Does that sound right? So it's even. +1. But let's see here. So we know the 2 ordered pairs we got for our system was 2, 4. So you can kind of check to see if the 2 lines are intersecting at 2, 4, and that will be this point right here. So it does seem to be intersecting, and then the other was 5, 25. So we do see the 5, but the y-axis doesn't go up to 25, right? So we wouldn't be able to verify that, but the 2, 4 we can see does match. So at least if one of those is matching, then hopefully our graph is on the right path. So let's see if we are. So save our graph. Questions? Anybody on Zoom? Okay, this one is saying graph your equations on the same grid to support your answer. And then, of course, we need to type out what our solution set will be. So this one you can see is actually a combination of an absolute value function because we have y equals absolute value of 2x. And the other one is a linear equation, y equals x plus 3. This one you definitely want to use substitution again. Because you can't really do elimination while your x is still inside the absolute value, right? So substitution will again work better for this side. So we are going to again substitute. It wouldn't matter since both of them are set up as y equals, but we can simply substitute the equation 1 into equation 2. So since both of them are set up as y equal to, you can literally just set them equal to each other, and that's what the substitution will look like. So this will end up looking like absolute value of two x is equal to x plus three. Now, I think it was what, chapter one, when we had talked about how to solve absolute value equations, so you might have to jog your memory a little. But when you're setting up your absolute value equations, you take two x is equal to x plus three, so basically you just drop the absolute value symbol, right? Or, because remember, absolute value is the distance of a number from zero, so we could be on the positive side of the x-axis, we can be on the negative side of the x-axis. So the other one, you would set it up as two x equals negative of the whole thing, x plus. So we don't know if the number is gonna come from the positive side or negative side, or both sides in this case. So make one side completely negative. All right, simplify, get your x by itself. So I'm gonna go ahead and start by subtracting x. Move it to the left-hand side, so that will be 2 minus 1, which will be 1x or just x. This guy cancels out, leaving us with 3. So we get x equals 3 from one side, or distribute that negative sign inside the parentheses. And you will end up with negative x minus 3. So when we actually move this x, it becomes positive. And you end up with 3x equals negative 3. Divide both sides by 3, and you are going to end up getting x equals what side? Negative 1. Two x values, put that back into your equation to find the y value. And let's see, this will be for x equals 3. I'm just going to use the second equation this time, so that will be 3 plus 3, which will be 6. So our ordered pair will be positive 3, positive 6. And for x equals negative 1, same equation. Negative 1 plus 3 will end up giving us what, 2? So negative 1, comma 2. Again, we're typing in ordered pairs, so negative 1, comma 2. Questions? And you will notice we're back to two variables, right? Only x and y, no longer the z variable, because in the second section, the 5.3, you are dealing with two-dimensional graphs. Alrighty, guys, let's check that answer then, if you have no questions. He's looking good. Now you will see you're actually not graphing. You are having to choose the graph. It looks like they're only giving us 3 options. Now obviously you have access to Desmos to do that, but the quickest one is, you can see that's a positive absolute value of 2x, right? Outside the absolute, you're not seeing a negative sign, which is the same thing we do when we're working with parabola. So that actually means your absolute value is opening up. So if it's going to be opening up, then it's going to be either this guy or this guy. This one, absolute value, is opening down, so we know it's not going to be C as the option. The other thing we know is positive x plus 3 as the other equation is going to be a straight line with a slope of 1 and a y-intercept at 3. And we know it's a positive slope. So if it's a positive slope, we know the line has to be going up like this. With negative slope, the line goes down, right? So you can see this guy here has a negative slope on that straight line. So that's not going to be your graph either. So the only one that meets the requirements is actually graph A. But like I said, you always obviously have access to Desmos to see what the graphs would look like. This honestly goes quicker than even having to type those equations into Desmos. And then the other thing you will notice is where the two lines are, or the two graphs are intersecting. So we had two ordered pairs of -1, +2. So that's right over here, this guy, and then the other one was +3. positive 6. So you can kind of see that general neighborhood, right? You cannot see the exact numbers, but you can kind of verify those points. So pretty confident we're looking at option A. Let me know if you watch the video and you have any questions, okay? All right, good luck. Anybody have questions on this example here, guys? Okay. All right. Before we do that, let's come back here. We kind of did something similar to that. We did something similar to that. Yeah, sure, why not? This one is a combination of, as you can see, a parabola and an absolute value put together. So just to kind of give you a rough idea, you're talking about a parabola with the absolute value, right? So you can see there should be 3 points of contact, right, between the two graphs. So let's verify that. We're going to use substitution again. And again, since they're both set up as y equals, you can just set them equal to one another. Same thing, since we are dealing with the absolute value of x, you'll set this up as x equals x squared or x equals negative x squared. Now you will need to solve this as a quadratic equation, so you will end up with x squared minus x equals 0 on one of those equations. And this guy, if I move him to be, you'll end up with x squared plus x equals 0. How can we solve, on looking on the left-hand side, how can we solve x squared minus x equals 0? Because we don't have a constant term, right? We don't have that plus c term. We just have the ax squared plus bx term. So how can we simplify x squared minus x equal to 0? What do we see common between the two terms? What do you mean by that? Yeah, x is common between the two terms, so go ahead and factor on x. So we can take one x outside as the greatest common factor, and you're left with x minus 1. Actually, the same thing's gonna happen on the other equation. You have x squared plus x. So again, x is common, bring that out. And you're left with x plus 1. So you can see, we're gonna end up getting x equals 0, or x minus 1 equals 0, or for the other equation, again, you get x equals 0, or x plus 1 equals 0. So you can see these guys are the same point, right? Because it's going to be x equals 0, you'll get the same y value for that. Kind of running out of space here. Let's find y. So let's see, if my x is 0, y will be x squared, which will be 0 squared, which will be 0. So your ordered pair will be 0, 0. If my x minus 1 is equal to 0, that of course tells us x equals positive 1. So y equals, and again, you can use either one of those. We'll do absolute value of 1. Absolute value of 1 is 1. So that ordered pair comes out to be 1, 1. And then the last one was x plus 1 is equal to 0, which means your x value is negative 1. Same thing, I'm just going to put it in the absolute value function, which will give us a positive 1. So you end up with the ordered pair negative 1, 1. So let's see, the three places where these graphs are meeting is 0, 0, negative 1, positive 1, positive 1, positive 1. Your absolute value function would graph like this. And then your parabola. A parabola with some. So, I mean, my graph is obviously not very nicely done, but those would be the 3 points where your graphs would intersect. And we can do a quick test moves if you guys want to see better drawing. Regular graphing, we have y. Absolute value. Like I said, you should be able to see 0, 0, 0. Positive 1, positive 1, and then negative 1. Negative 1, positive. Yeah? Alrighty. So that was using substitution. Now, this is where we're getting into a little bit of a different type of system of equations. So you can see these guys kind of sort of look like equations for circles, which again, we had talked about in chapter 1. Chapter 2. Talked about circles back to back, so I think it was maybe chapter 2. We'll be talking about circles again in chapter 7, actually. But obviously, we're talking about circles in chapter 5 also. So some of these equations, just to show you what they might look like, will be, a little bit different looking. This is actually the intersection of the circle with an ellipse. So he will actually look like, kind of looks like this. And an ellipse, right? How many points of contact are you seeing? 4, yeah. So there's going to be 1, 2, 3, and 4. So let's see what those points will look like. So we'll actually pick up the example from my math lab for this guy. So let's come back here. Let's look at this. This one actually looks like intersection of 2 ellipses instead of a circle and an ellipse, but it should still be a similar idea, right? So, and I don't know what the orientation for this is. I'm just doing a very rough sketch, but you can see we'll still have the 4 points of contact, right? 1, 2, 3, and 4. So it would kind of look similar, even if they're moving around in different. Question. Alrighty, so let's take a look at how we would solve this. So you have 2x squared minus 4y squared equals -8, and then 5x squared plus 3y squared equals 32. So treat them x squares, y squares as though they were x and y and follow that same idea. So eliminate either the x or the y. So which one do you think might be easier to eliminate in this example? X or y? Because I don't think any one of them is any easier than the other, right? I mean, there's no single equation that we can multiply and this would work. So you can honestly pick x or y. Maybe y because you have the minus sign on it. Yeah, let's do that. So we will, and they are asking us to use the addition method here. So that's what we're doing. So let's start by eliminating y squared. But you can call it y, it doesn't matter. So that's equation 1. All that. So what would we need to multiply equation 1 with? And what will we need to multiply equation 2 with so that we can cancel out the y squared? What would be the least common factor between 4 and 3? Well, yeah, so what we multiply equation 1 with? And equation 2? There we go. Alrighty, so we are going to multiply. then we'll add. Let's see, that will end up giving us 3 2s are 6x squared minus 3 4s are 12y squared. 3 4s minus 3 times 8 is what, 24? Then, equation 2 will have 4 times 5. X squared plus 4 times 3 is 12, 12y squared equals, oh Lordy, what is 4 times 32? 4 2s are 8. 3 times 4 is 12, so 128. Alrighty, so of course, as we had hoped, the negative 12y squared, positive 12y squared will cancel each other out. Leaving us with, let's see, we're adding, so that will become 20 plus 6, 26x squared. Well, let's see. What will that be, 104? 128 minus 24? That will be a positive 104, which means to, oh, bless you. So to get x squared by itself, we'll go ahead and divide both sides by 26. So what is 104 divided by 26? That did come out again, I think. 104 divided by 26 will give us 4. Alrighty, very nice. Danny, I see your answer. Yeah. So again, guys, because you have x squared, we'll need to use square root. And since you're going to be using square root, remember that gives you a positive and a negative root on your answer. So you'll end up with x equals plus or minus 2. And we should come up with 2 answers, because remember how we showed that there will be 4 points where the graphs will be moving. So you are actually going to come up with 2 x values, which will convert into 4 orbit pairs. So let's see how that works. Anybody has questions up until this point? You okay? All right, let's take a look. All right, so let's find the y value next. So we'll start with x equals positive 2 first. And I'll use the second one, 5x squared plus 3y squared equals 32. Our x value is 2, so that will go as 5 times 2 squared. So that becomes 5 times 2 squared. 2 squared will become 4. 5 times 4 will of course become a 20. Subtract the 20 on both sides. So you will end up with 3y squared equals, what's that, 12? Divide both sides by 3. 12 goes into 3, what, 4 times again? And 3 goes into 12 4 times. What's your y value going to come out to be for this guy? Yeah, same thing. So square root on y squared will end up giving us y equals positive or negative 2. Now remember, guys, we just started out with 1 x value, which ended up giving you 2 y values. So you will end up with x was 2 with positive 2 for the y, and x was still 2 with negative 2. So from 1 x value, you came up with 2 ordered pairs. And then we still have to do the y x equals negative 2 part. So x equals negative 2 to find the other 2 ordered pairs. Same equation. So 5 times negative 2 squared plus 3y squared equals 32. Again, you're taking negative 2 to the second power, so that will become a positive 4 times 5, which will again be a 20, and you will actually see we're almost repeating the same calculation because your four ended up becoming a positive four. So pretty much the same math is being repeated at this point. So move the 20 to the other side, divide by 3. You get y squared again equals 4. Take the square root on both sides, and again, you end up getting y equals plus or minus 2. The only difference this time is going to be, we started with x equals -2, so you'll have -2, +2 as one of the ordered pairs, and -2, -2 as the other. So your solution set will be 2, 2, 2 and -2, then let's see, -2, +2, -2, negative. So it's honestly a combination of +2s and -2s, right? That's what your 4 ordered pairs would amount to. So let's see, 2 and 2. -2, -2, +2. Check this guy and then we have these. Most of the time I have seen that those 4 answers will have that pattern, right? The +2, -2, and then the alternative signs and the same signs. Anybody questions on this color here? No people? Okay, no questions? Let's see. Ah, do this. And we will actually. So we have 3 over n minus 1 over y equals 13 over 10. We have 1 over x plus 2 over y equals 9. But don't get scared just because you are seeing fractions in there. Treat it the same way like you would if it was -y or -2y or +2y, right? In that same sense. So for now, we're going to leave our x and y on the denominator. We're going to keep the fractions as it is. So basically what you need to think is if I had -2 over y and if I had +2 over y, they would be opposites of each other, right? And I could cancel them out. So how can we make that first equation have -2 over y? What would we need to do? And the reason we're picking y is because we already have the built-in negative sign in there, right? So that's why we're eliminating y. So what would you multiply equation 1 with? Yes, you will multiply by 2. And if visually it makes it better, you can think of it as 2 over. So whatever works out. There's space here, so that will of course mean we're multiplying 3 times 2, which will make it 6/x, because x gets multiplied with 1. Minus 2 times 1 is 2, so that becomes 2/y. Equals 13 times 2 is 26, so that will become 26/10. So that was from equation 1. Equation 2 will stay as it is. Eliminate. 1/x plus 2/y equals 9/10, and then we're gonna add these guys together. So the adding will be easier here because our denominators match, right? So of course, we know -2/y and +2/y will cancel each other out. And then when you are adding, you are taking, and again, I'll show this on the side, 6/x is being added with 1/x. So this is what I meant. You have the same denominator, so you're just adding 6 plus 1, which will make it 7. So this guy will become 7/x. Y, of course, got canceled out. On the other side, you have 26/10 being added to 9/10. So again, same denominator, keep the 10. And what's 26 plus 9?
35.
35. So now you have 7/x equals 35/10. Remember, this is what proportions look like. Does anybody remember how we solve proportions? Cross product, right? We're gonna do cross product. So you're gonna multiply 7 times 10. You're gonna multiply x with 35. So that will end up giving us 35 times x. 7 times 10 is what, 70? What does the x value come out to be? Yeah. And once you have x, you can go and find y. What space? Guess I'm gonna use equation 2 to find y. So equation 2 was 1/x plus 2/y equals 9/10. So if x equals 2, that fraction will actually end up becoming 1/2. So we'll start by subtracting the 1/2, moving into the other side. And we will end up with 2/y on one side, and then let's clean up the right-hand side. So we're taking 9/10, and we are subtracting 1/2 from it. Now, you guys can use a calculator to do this if you wanted to, but I know I just can multiply 5 on that second fraction, which will end up making it 5/10. So once I have my common denominators, I can subtract that, which will of course end up making it. What's that, 4/10? The same thing, right? Proportion 2/y is 4/10, so do cross product again. Which will, let's see, give us, well, 4y is equal to 20. Divide both sides by 4. And y equals 1.
5.
So our solution set would be over there. So the equation may look scary, right, when you're starting out, but honestly, these guys are not too hard to solve. Just as long as, I guess, the fractions don't freak you out. Questions on this example here? Okay. If you do not have a question, let's take a look at this guy from my math class. So as you can see, guys, this is a combination of, exponential and logarithmic functions. I mean, we've got y equals 11 to the power of x, and x equals log of y with base 122. So I would definitely recommend you guys to use substitution to solve this type of example here. That's equation 1. Equation 2, and I guess I am substituting because I think I want to put the 11 over x or 11 to the power of x inside my model. So we're going to substitute 1 inside. Means we will end up getting x equals log, which has a base of 1.1, and this is where the replacement is happening. So we're actually replacing y and taking what was equation 1 equal to. So that's what this question. And the reason why I'm doing this is so that I can use this idea of when you have exponential format, which then becomes a to the power of y plus b. So in our case, that would be base 121 to the power of x equals 11 to the power of x. And we're going for that 1-to-1 property, right? If the base is max, then we can set the exponents equal to each other. So how can I rewrite 121 as something with base 11? Like 121 has 11 to the power. Yeah. 121 is 11 squared. So you can rewrite this guy as 11 to the second power to the power of x. So again, using the exponential properties, I can multiply the two exponents on the left and it will become 11 to the power of 2x equals 11x. And this is where that 1-to-1 property for exponential functions will kick in. You can say 2x is equal to x. Do not divide by x here, guys, because that will eliminate the variable. Subtract. Subtract and bring the x to the left-hand side. 2x minus x is 1x. X equals 0. If x equals 0, what is your y? Yeah, very nice. So the ordered pair then ends up becoming 0. Anybody have questions on this little guy here? Please simplify your answer, type in ordered pair, so 0, 1 should be 8. Is they're not asking you to graph, it's just come up with the solution set. Okay? Yeah? That was the last example from 5.3. Let's actually do number 7. Because if my memory serves me right, I think there might be something like number 7 in one of it. So they're asking us to find two complex numbers whose sum is 6 and product is 10. So think of the two complex numbers as maybe being x and y. So when they're saying the sum of the two complex numbers is 6, that actually means if I add the two numbers, I should get a total of 6. And the other one says whose product is 10, which means if I multiply the two numbers, the product should come out to be as 10. So we'll call that guy equation 1, call that equation 2. We will need to use substitution again for this guy, because since you have x times y, we really wouldn't be able to do addition or elimination method here. So I guess it wouldn't matter, but we can substitute. Let's maybe rewrite equation 1 as x equals 6 minus y, right? By moving the y to the other side. And so then we can substitute equation 1 into equation. So you're substituting for x. So we had x times y equals 10. So we're substituting for x by the rewrite of the equation 1 we did, which was 6 minus y. And we're doing this so we can keep it to one variable, right? So we are only dealing with y or only dealing with x. So now we'll need to solve this. So go ahead, distribute that y inside the parentheses. You'll end up getting 6 times y minus y squared equals 10. And then we can solve this like a quadratic equation, right? So I'm actually again going to go ahead and move both of these guys to the other side. So when I move y squared to the other side, v becomes positive. 6y will become negative, and then the 10 stays where it's at. So plus 10. Can I factor this? Two numbers that would multiply to give me positive 10, but add up to give me negative 6. 10 is 10 times 1 or 5 times 2. Neither of those combinations is going to give us negative 6 when we add them, so we might have to do the quadratic formula. Okay, so this guy did not work. Let's do the quadratic formula. So your quadratic formula will be negative b plus or minus square root of b squared minus 4ac, and then the whole thing divided by 2a. So let's see, our a value is positive 1, b value is negative 6, c value is positive 10. So that would be negative b plus or minus square root of b squared minus 4 times a times c. And then the whole thing divided by 2a. So be careful because your 6 does have a negative sign on it. So that first part of the quadratic equation will have 2 negatives. So negative and negative will end up actually making that into a positive 6. Plus or minus under the square root, negative 6 squared will become positive 36. Minus 4 times 1 is 4, 4 times 10 is 40, so negative 40 divided by 2 times 1 is 2. And you can see, guys, they did tell us complex numbers, right? So which means we should have that imaginary number I show up. So that 36 minus 40 underneath the square root is kind of hinting towards that. All right, let's see. So this will become 6 plus or minus 36 minus 40 is negative 4. Divided by 2, you can see that. So I'm going to separate that 6 divided by 2 plus or minus How can I rewrite square root of -4 with the imaginary number? Square root of -4, how are you gonna rewrite that with the imaginary number I? How do we simplify that, guys? Does anybody remember how we define the imaginary number I? Square root of -4. Say that again? I wish, dude,
You should.
because you're not gonna give me answers. There's other things I can be doing right now, like grading. All right, separate the 4 and the -1. So square root of 4 is 2. Square root of -1 becomes I. That cleans up into plus or minus 2I. And then we're basically taking that denominator of 2 and splitting it into the real and the imaginary part. So this guy cleans up into 6 divided by 2 is 3. 2 divided by 2 is 1. So that cancels out, leaving you with 3I. So your two complex numbers are actually conjugates of each other. 3 plus I and 3 minus I. When you add them together, they're gonna add up to a 6. When you multiply them together, they're gonna multiply into a 10. If you wanted to check that, oh, I have one space for it, but let's do a quick check on it. So when I multiply add 3 plus I with 3 minus I, that will be 3 plus I plus 3 minus I. So the positive I, negative I cancel each other out. 3 plus 3 is 6. So the sum is 6. That checks out. For the product, 3 plus I multiplied with 3 minus I. Of course, we'll have to do FOIL. So 3 times 3 is 9. 3 times negative I is negative 3I. 3 times positive I is positive 3I, and then positive times negative I will become negative I squared. Of course, positive 3I, negative 3I will cancel each other out. You're left with 9. If I is square root of -1, I squared is actually -1 itself. So you end up with the minus sign from here, and then I square itself also becomes -1. The negatives become a positive. 9 plus 1 is a positive. Okay, so you will get two conjugate pairs as your two complex numbers with this type of example. Question. As much as you guys would like to go home early, you're not. So get on your laptops, get on a computer, work on your finish chapter 5, how much you can do, and I'm here to help you out if you get stuff. You do not leave till 3:55, I'm sorry. I am like that. What can I do? Because you guys don't work on your homework till I have to threaten you or punish you that you cannot take the exam. You're probably done with chapter 5 if I remember. Oh, you can work on chapter 7.
Already finished it.
Yeah, work on the practice final exam. Chapter 5, chapter 7, and final
Wait, when's our chapter 5?
Thursday. Even those of you who are on Zoom, you can stay on Zoom and just get on my math lab and work on your homework questions from chapter 5. We have 15 minutes in class, so that does give you good time to work on some questions and ask for help if you get stuck on anything.
You know what I mean.
So it will count against attendance, anybody who leaves early. I
For
think.
15 minutes?
Yeah. I'm not dismissing class.
Wait, so what's like 15 minutes of attendance?
Anytime you leave a class early, you lose half attendance. So you will only get 0.5
That's
attendance
crazy.
points.
Crazy.
I've been teaching long enough to know you guys are always trying to find the easy way out, sorry. You are suffering from all the other people who've tried to get the best of me, so you do not get an easy way out.
That's unfair.
That is unfair, what can I say? Yeah, let me make sure.